So this chapter is current electricity of grade 9 physics, chapter number 9. In current electricity, the first topic, that direct current. Okay, in source of direct current, you have a cell. A cell is a source of direct current. Usually, we see a cell which is denoted like this. Okay, there is a positive terminal and there is a negative terminal. So a cell is usually denoted by, this is a symbol for a cell. And in a cell, there is chemical reaction that takes place, and we have chemical energy that gets converted to electrical energy. Okay, and many these cells which are joined together, one below the one next to each other. So you have positive, negative, positive, negative. So that constitutes a battery. So this is plus and minus. So from these cells, the current that we get is called as direct current, because if you see, this is time, which is in seconds, and if this is potential, okay, which is measured in volt, we will see that in the second exercise. So that is constant, okay? The potential will be constant. So that potential can be, say, around 1.5 volt. It remains the same. That is why it is called as direct current. In the textbook, they have given you a diagram like this. So there is positive and negative, and there is a bulb connected like this, and the bulb will glow. So this is a source of direct current. Okay. Now in direct current, there are kinds of cell. So in kinds of cell, you have primary cell, secondary cell. Okay. I have already told you that in a cell, you have chemical energy that gets converted to electrical energy. Okay. In a primary cell, this chemical energy to electrical energy, that reaction is irreversible. But in a secondary cell, it is reversible. That means in a secondary cell, we can charge it back. We can, make it work again. But in a primary cell, once it is used, okay, you have to replace the cell with another cell. But in a secondary cell, there is an option, we can charge it again and use it again. So like our phone battery is an example of a secondary cell. The cell that are there in your remote control of the television or the AC, those are primary cells. Okay, those can't be charged again. There is a word that is used over here, that is internal resistance. Remember, inside a cell, generally, if you have seen an electrolyte, cations and anion, anode and cathode, and there are two type of charge in the electrolyte. Now, these charge flow inside that electrolyte, so they experience resistance. Okay, resistance is basically obstruction to the flow. So the resistance that is experienced by these cations and anions inside a cell is called as internal resistance of a cell. Okay, so that is a resistance that is experienced by the cations and anions inside a cell will be called as internal resistance. So in a primary cell, the internal resistance is more. In a secondary cell, the internal resistance is less. You can also remember the names of some of the primary cells, like simple voltaic cell, Leclanche cell, and Daniel cell. Okay, or what we inside the remote is a dry cell. Then you have lithium ion battery that is there inside the phone, which is a secondary cell. And there is lead acid accumulator, which is generally what the car batteries are. Okay, so that is the difference between primary and secondary cell. Electric current. Now, current flowing in a wire, that means electrons are flowing inside a wire. That electric current is defined as the following. Okay, electric current is the rate of flow of charge across a cross section normal to the direction of flow of current. Okay, so if you have a wire like this is called as a cross section of a wire, and normal means perpendicular to the wire. So when you have these electron flowing in a wire, how much charge flows in a given time is called as electric current. So we have electric current will be charge upon time. Remember, charge is measured in coulomb, time is measured in second, and electric current is measured in ampere. Okay, current is a scalar quantity, and yeah, the letters. Electric current is denoted by I, ampere is denoted by A, Charge is denoted by Q, but Coulomb is denoted by capital C. Time, we know it is denoted by T, and second is small s. Okay, current is a scalar quantity. Scalar quantity means which do not require direction. Okay, only magnitude. So like for example, current in a wire is 5 amperes or 15 amperes. So that we are talking about the magnitude. Fine. Then over here, charge on one electron, it is 1.6 into 10 to the power minus 19 coulomb. That is the charge on one electron. Then this, they are talking about how many electrons do you need to make 1 coulomb. So this is 1 coulomb, where n is an integer. So over here, n will be 1 upon 1.6 into 10 to the power minus 19. Now, how do I do this division? I take the 10 to the power minus 19 above, and this is 1.6. So if I shift the decimal, I'll get 16 upon 10, and this is 19. If I make the 19 as 18, I'll get 100. So 4 4s are 425s are. So this will be 6.25 into 10 to the power 18. So what does that mean? 6.25 into 10 to the power 18 electrons will have a total charge of 1 coulomb. Okay, so that's a pretty high amount of number of electrons to get 1 coulomb of charge. Fine. The next is quantization of charge. What do you mean by that? It is written like this: Q is equal to plus minus a number times electron. That means a body can either gain 1 electrons or 2 electrons or 10 electrons. A body can never gain a half an electron. A body can never gain 3/4 of an electron, or lose for that matter. So that is the reason why the number of electrons which can be gained or lost will be always integer times electron. That means 1 electron, 2 electron, 100 electrons. So that is the reason why this is called as quantization of charge. Here we have definition of 1 ampere. In the previous slide, I told you that electric current is equal to charge upon time. Okay, and electric current is measured in ampere. So 1 ampere is 1 coulomb upon 1 second. Okay, so this is how you define 1 ampere. So in a wire, through a cross section, if 1 coulomb of charge flows in 1 second, the current in wire is said to be 1 ampere. So that is the definition of 1 ampere. Okay, so through the cross section of a wire, if 1 coulomb of charge flows in 1 second, the current flowing in the wire is said to be 1 ampere. Okay. Now, as you saw that for 1 coulomb of charge, you need a very high number of electrons. Okay. So that is the reason why 1 ampere is a pretty high amount of charge. So therefore, we use milliampere, which is 1,000 part of an ampere, and microampere, that is 10 lakh part of an ampere. So these are same as we have studied in chapter 1, milli and micro. Then current inside an electrolyte. In your textbook, they have mentioned that I is equal to N1 times plus Q1 minus N2 times minus Q2. Okay, so this has to be upon time, but they are talking about a unit time. So therefore, that time is not mentioned. I'll write over here 1 second. Okay. Now, what does that mean? As I told you, inside an electrolyte, there are positive charge flowing in one direction and negative charge flowing in the other direction. So positive charge has a charge Q1 on it, and there are N1 number of positive charge. So therefore, the total amount of positive charge is N1 times Q1. The negative charge has a charge Q2 on it, and there are N2 number of negative charge. So therefore, the total charge is N2 times Q2. Then the total charge is said to be Q1 minus Q2. The reason is that this is negative, because if you have plus 10 charge and you have minus 2 as negative charge, the total charge will be plus 8. Okay, in the same way, if you have +5 charge and -7 charge, the total charge will be -2. So this is the meaning. There will be no numericals. It is just a statement on the second page of this chapter. Okay, so I am explaining that to you. Inside a metal wire, you have electrons flowing. There are only electrons which flow in a metal wire. However, inside an electrolyte in a cell, there are positive charge as well as negative charge flowing. The next is conventional direction of current. So a simplest circuit that I can draw, I have a cell, I have key, there is some resistance I can show, another resistance, and yes. So this is like a simple circuit. In this circuit, this is positive of the cell, this is negative of a cell. When we are showing direction of flow of current, you always show from positive to negative. So this is called as conventional direction of current. Okay. However, when you talk about electron flowing, so electrons which are negative in nature flow from negative to the positive end of the circuit. So the electronic direction will be from negative to positive. So the conventional direction of current, where current is said to flow from positive to negative, electrons flow from negative to positive. Okay, so this you need to remember. If they ask what is the direction of current, we always talk in terms of conventional direction. But if they ask you where are electrons flowing, so electrons are flowing negative to positive, that is opposite to the conventional direction. Moving to the next part, the symbols that are used in electrical circuit diagrams. Number one, source of current. In source of current, we have two type of sources, direct current and second is alternating current. So direct current, as we have seen, we receive it from cell. So this is how you draw the symbol, positive and negative. So this is cell. And if you connect more than one cell together, that will be called as a battery. Okay. Remember, the lines that you draw should be very distinct. One is taller, one is shorter. Alternating source of current basically means that the voltage that is there, okay, it keeps changing with time. Okay, so like in our house, we have 220 volt and this is minus 220 volt. So that keeps changing. So alternating, you don't need to know this. All you need to know is a symbol. So the symbol is drawn like this. Okay, there is no plus and minus to that. So you draw a wave and you draw a circle. Okay, so that is how you draw an alternating current. Fine. And what is the function of this? To provide current to the circuit. Okay, then you have keys. In keys, you have switch, okay, on or closed. This is off or open. Okay, let me just tell you the meaning of that. If this is a circuit diagram, now at any instant when the circuit is broken, the current will not flow. So this is called as open. That means the circuit is as good as off. And when everything is closed, then the current will flow. So that is called as closed or the circuit is on. So you need to get used to these words. The circuit is closed, that means the current will flow. When the circuit is open, the current will not flow. So a switch, a closed switch, an open switch is denoted this way. Okay. The next thing is a plug key. A plug key is denoted in this fashion, which is on. There is a dot. And over here, there is nothing over here. So that means it is open or the current is off. Tapping key. This is how you show a tapping key, which is closed. And this is a tapping key, which is open. There is no contact. Okay, I'll show you how they look in this. So this is a plug key. Okay, so you can see that over here, the key is not inserted. Therefore, this is open. And in this, the key is inserted. So it is closed. Okay. So this is for a plug key. Then you have the tapping key. So this is the tapping key. Here you have to press this. So they will be in contact. The moment you let it go, the circuit will be broken. In resistance, there is resistance wires. Remember, students, connecting wires are usually copper. There can be aluminum as well, but copper is a metal that is preferred to connect wires in an electrical circuit. But there are certain materials, alloy, like constantin, manganese. These wires have resistance more, okay? They have higher resistance, 40 times, 50 times that of copper wire. So alloy like manganese is there, constantin is there. So these have resistance which is more than that of copper, 40 times, 50 times that. That's why they are used. Now they have fixed value, okay? Depending upon the length of the wire, depending upon the thickness of the wire, they have fixed value of resistance. And that value is something like, say, 50 ohms. It can be 100 ohms. So those are fixed value resistors. So you can see that these are the fixed value resistors. And the color on the resistor, the color band, determine the value of the resistance. You don't have that. But just for your knowledge, the color bands determine the value of resistance. So this is called as a fixed resistance. Okay. Then we move on to resistance box. Now this has a variable resistance. Okay, so that I'm going to again take you to the, so this is a resistance box. Now on the resistance box, here we have the keys. Okay, so these are the keys, plug keys, and these are the connecting sources. So the wire are connected over here. Now over here, it's not visible in the image, but there are numbers written over here, like 1, 2, 2, 5. There will be 10, 20, 20, and say 50. This is an example I'm giving you. There can be different value of resistance. Now, how does this work? Now, when you remove the key, okay, say for example, you remove this key and this key, you remove it. So it will be open now over here. So in the circuit, the resistance that will get added will be of 3 ohms. Okay. If you remove one more, say for example, you remove this 10. So now the total resistance will be 10 plus 3, that will be 13 ohms. So a resistance box helps you to add variable resistance, different value of resistance can be added. In this particular resistance box, you can add any value from 1 ohm to 100 ohms, okay, integer value. So for example, if you want to take 67 ohms, so I can remove 50, I can remove 10, I can remove 5 and 2. So I will remove a 50 ohm key, I will remove a 10 ohm key, a 5 ohm key, and a 2 ohm key. So I will get 67 ohms. That way, I can get any value between this. A fixed value resistance is denoted just by this arrangement, okay? While a resistance box, you have like a arrow symbol. So that shows that it is variable. The next is a rheostat. Okay, so let's again go back over there. So a rheostat is something like this. Okay, this is a device which is called as a rheostat. So for a rheostat, just understand that let's say you have a very long wire. This long wire can be like say 5 meter long, and this has a resistance of 1000 ohms. Okay, so 5 meter long wire has a resistance of 1000 ohm. Now 5 meter is long. So what do? They wrap the wire around. Okay, so in on the cylinder, there will be like wires which has been wrapped around like this completely. So if you take this terminal A and terminal B, so between them, the resistance is 1000 ohms. Now here you see this is a metal rod, and this terminal is C. And over here, there is, this is a metal conductor, which is clamping the wire. Now, Imagine that current enters from here. The current will flow through these many turns and the current will flow out from there. So if I shift the clip to the right, so if the clip is over here now, instead of being over there, the current will flow through more number of turns and it will flow out. So earlier the current was flowing through only this length of the wire, and now the current is flowing through a longer length of the wire. That means the resistance has increased. So if you shift the clip to the right, you increase the resistance. If you shift it to the left, you decrease the resistance. So this is a rheostat which allows you to change resistance from 0 ohm to 1000 ohms. Okay. The advantage of a rheostat, you can have any value. Like in the resistance box, you only had integer values. But the disadvantage of a rheostat is you will not know the value. Okay. In a resistance box, that it tells you 60 ohms, 62 ohms. Here, you will not get that. Okay. So that is the difference. And a rheostat is represented by this symbol. Moving ahead, we have ammeter. The purpose of an ammeter in a circuit is to measure the current. So a simple diagram like this. For a voltmeter as well, it is plus and minus. And for a galvanometer, you have a G written over there, but there is no plus minus. So ammeter measures potential current in the circuit. Voltmeter measures the potential difference, and a galvanometer measures the direction of flow of current. Okay, so I'll show you the diagram, but before that, let me just draw a small sketch to make you understand that. So this is where the readings are taken, and there is a pointer, so that tells you the reading. This is 0, 1, 2, 3, 4, 5. Okay, and here there are connectors, so you connect the wire. This is plus minus. Sometimes it can be down over here as well. So A will be written over there, so that indicates it's an ammeter. There will be a V written over here that will indicate it's a voltmeter. But if it is a galvanometer, then in this you have a 0 written over here. Okay, and you will have 1, 2, 3 on either side. So for a galvanometer, the 0 is at the center. So let me just show you. So you can see in this particular diagram, there's a picture of a voltmeter, this picture of an ammeter, and this is of a galvanometer with 0 at the center, and there are numbers on either side. If the current is flowing in one direction and it deflects on the left, if the direction of current is reversed, then it deflects on the other side. So therefore, a galvanometer helps you determine the direction of flow of current. There is a load. Okay, anything which offers resistance is called as a load. So you can have a bulb. So a bulb is denoted by a filament like this. Okay, and then a heater element. So when you have a resistance in circle, so that is called as a heater element. So this is a bulb, this is a heater. So they are called as load because they are uh, giving you resistance. The next is connecting wires. So as I told you, copper is a preferred metal to make connecting wires, because copper has a ability that it can be drawn into thin wires, and it also offers less resistance. In an electrical circuit, suppose I connect a circuit like this. There is a key. Suppose if I draw a bulb, there will be, say, some resistance. I have also a rheostat added over there. Okay, so everything is fine. Now, if I have to connect an ammeter, why do I connect an ammeter? To measure current. So the ammeter I will connect this way. If I want to know the potential difference across the bulb, so I will have to connect a voltmeter whose two ends are on the either side of the bulb. This way of connecting is called as parallel connection. And this way of connecting in line with all appliances, it is called as series connection. So the ammeter is connected in series, a voltmeter is connected in parallel. Always you need to write the plus and the minus, and of course the direction of current is required. This is a rheostat, this is a normal resistor. This is a positive of a battery, so the terminal of an ammeter closer to that will be positive. So if, say for example, I connect an ammeter over here, then this end I will call it as negative, that is closer to the negative end, and that end I'll call it as positive. Similarly, for the voltmeter, this end will be positive, so that is toward the positive side. Then you have an insulator. Insulator is something which do not allow the current to flow. And then you have a conductor which allows current to flow, which offers less resistance. So those are called as conductors. Closed circuit, I have told you, whenever the circuit is closed, that means current will be allowed to flow. And when there is a gap in the circuit, current will not be permitted to flow. So that is called as open circuit. In electric potential, there is an idea that what do we call as more potential? Okay, so more electric potential. So where the a number of electrons are more, that is said to be as a lower potential or a negative potential. The conductor which has less electrons or which is more positive is said to be at a higher potential. So to give you an example, this is one such example. So this is a conductor A, this is conductor B, and there is a wire connecting them. So in this, B is at a lower potential. So therefore, electric current will flow from a higher potential to lower potential. So in this particular case, current will flow from A to B and electron will flow from B to A. Now, if I give you one more example, now if I connect them this way, so this is A and this is B, current will flow from A to B.
A to B.
Yeah, A is more positive. Okay, A is more positive. So therefore, A is at a higher potential. And B, which is less positive, will be at a lower potential. I'll give you one more example. So now what do you think? Where will current flow from?
B to A. B to A.
Go from B to A. Very good. So it is less negative. So it will be a higher potential. And so the electron will flow in the other direction. Okay, so this is how you determine the flow of current. The flow of current always flow from a higher potential to lower potential. The same thing is demonstrated in many other examples. So if you are on ground, then anything that is released will go down. Okay, so A is said to be at a higher gravitational potential, B is said to be at a lower gravitational potential. If you take an example of, say, there are two bodies, this is 80 degrees and this is 30 degrees. So heat will flow from A to B. Okay, heat will flow from A to B. So higher temperature to lower temperature. So electrons will flow from higher potential to lower potential. Electric potential. Now, what I told you in the previous slide, you should know that to identify the direction. But here there are certain definitions that you need to learn. So first is definition of a potential. So if they ask what is the potential at a point, then what does that mean? The work that you need to do to take a charge from infinity to that point, the work done is potential. Okay, so potential is work done per unit charge to take it from infinity to that point. So that is definition of potential. Then potential difference. So this is point B, this is point A. There is a charge over here. And if you are taking that charge from A to B, then the work that you do to take that charge is called as the potential difference between the 2 points. So this is another definition, potential difference. Okay, so what does V stand for? It stands for potential. What does W stand for? Work. And Q stands for charge. And charge is measured in Coulomb.
Coulomb.
So potential is measured in volt. Okay, so therefore, you have 1 volt equal to 1 joule upon 1 coulomb. So therefore, we have definition of volt. So the potential difference between the points VB minus VA is said to be 1 volt if you take a charge of 1 coulomb from A to B, and to do that, you have done 1 joule of work. So if you spend 1 joule of energy to take a charge of 1 coulomb from point A to point B, then the potential difference between those points is said to be 1 volt. The statement of the law is important. Now, in the textbook, in a finer print, it is given. Ohm's law states that current flowing through the conductor is directly proportional to the potential difference applied across the ends, provided the temperature is constant. Circuit diagram to verify Ohm's law. So this is also important, like a 2-mark question it will be. So I will quickly draw the diagram. You have a resistor, you have a power source, there is a key. So this is a simple circuit. But now, remember, Ohm's law says that if you change the potential, the corresponding current will also change if the resistance is constant. So this is our resistor. Now, how do I change the voltage? For that, I need a rheostat. So that is the reason why I am putting a rheostat over here. Okay. But now I have put the rheostat, so that will alter the voltage, and correspondingly current will also alter. But how will I know? I need to measure that.
But so won't the rheostat also change the resistance?
Exactly. So this is a power source. If you change the resistance, then the voltage will change. But when they say resistance is constant, we are talking about this resistance. Now, if I want to measure voltage and current, so I need an ammeter. So let me add an ammeter over here. I need to measure the voltage across the resistor. So I am putting a voltmeter across the resistor. So this is the reason why they are there, because you need to measure voltage and you need to measure current. And obviously, what is left? The arrows representing the current and the plus and minus for the voltmeter. So this is a diagram to verify Ohm's law, and that will give you 2 marks. Okay, it doesn't matter if the voltmeter is down. It's the same thing. Okay, it has to be across the resistor. Then you have the equation. So V is proportional to I. If you increase voltage, current increases. If you decrease voltage, current will decrease. And when you remove the proportionality sign, you multiply by a constant, and this constant is called as resistance. So here we have V, which is measured in volt. We have I, which is current, which is measured in ampere. R, that is resistance, which is measured in ohm. So V is written as V, ampere is written as A, ohm is denoted by this symbol omega. It's a Greek letter omega. Okay, then you have factors affecting resistance. So students over here, if there is a wire, the wire has positive ions, which are the atoms of the wire. They are fixed. They will not go anywhere. They are just vibrating in their own place. And then you have electrons. So electrons are moving in random direction. So the net flow of electron is 0. However, when there is a potential difference applied, over here I will say that net flow of electron in one direction is 0. Now, if I take a wire, same wire, and I make one end positive, one end negative, then what will happen? The electron will all start moving in a particular direction, that is toward the positive, and that is called as current. So there will be electrons flowing in one direction. So this is called as electric current. Okay. Now, when these electrons are flowing, they hit against the atoms and they lose energy in the form of heat, which is called as resistance. So we are now going to study what are the factors which affect the resistance. So in that, one is material of the wire. So there are materials like copper, which offer less resistance, and material like nichrome, which offer more resistance. This is also denoted by a letter. This is rho, which we used earlier as density. And another name given to that is called as resistivity, or it is called as specific resistance. Okay. What else? Length of the wire. Resistance is proportional to length. That means if you take a longer wire, there will be more collisions with the electron and an atom, so the resistance will be more. Area of cross section. So resistance is inversely proportional to the area of cross section. That means a thicker wire will offer less resistance and a thinner wire will offer more resistance. Another factor is temperature. Resistance increases with increase in temperature. So if you heat the wire gets heated, the atoms tend to vibrate more, and therefore the chances of electron colliding increases, and therefore the resistance increases. So these three things are written together as this. Okay, so resistance of a wire is given by this symbol. I will write down the formulas which we used. So I is equal to Q upon T, current is rate of flow of charge. Q is equal to N times E. So N is a number, integer. We have used V is equal to W upon Q. V is potential. And we use V is equal to IR. So we have the physical quantity and we have units. So physical quantity is charge, which is denoted by Q, and the unit is Coulomb, which is denoted by capital C. Then you have current, which is denoted by I and which is measured in ampere. Then you have potential, which is denoted by V and it is measured in volt. That is also V. Okay, and other quantities that you know, like work, which is W, is measured in joule. See, these are all name of people, so they are capital letters. And then you have time, which is T, which is measured in second. Okay, and you have resistance, that is R, which is measured in ohm. Another person's name, but they have used a Greek letter instead of a capital O over there. Yeah, so these are the formulas based on which numericals will be done. The C exercise talks about efficient use of energy. That means using LED bulbs so they consume less power, using appliances which have a higher star rating so they use lesser power, avoid wastage of electricity, okay, and spread awareness through social initiatives and all that. Okay, so this brings us to the end of this class. Thank you, everyone.